Okay, so now we're going to look at some exponential equations. We did log in the last video. And we're still looking for this property right here. If you can get the bases to match, then the exponents have to be the same. That one is still true. And we're also going to add in the method that we saw with the change of base formula. So we're going to kind of put those two together, and we should be able to solve exponential equations now. So let's say we have something like 5 to the negative x plus 3 is equal to 25, and we want to solve this. The first thing you should always ask is, can I get the bases to match? Because if you can get the bases to match and use this property, that's still the best route to go. That's the most foolproof, let's say. Less likely to go wrong. So can we get these bases to match? Yes, we can. We get them both to a base of 5. So we can rewrite 25 as 5 squared. The bases match, so the exponents have to be the same. So we're going to have negative x plus 3 is equal to 2. Subtract 3 from both sides. We get negative x is equal to negative 1, or in other words, x is equal to 1. Okay, and you should be able to come back up and check that. If I put a 1 in here, 3 minus 1 is 2, and 5 squared is definitely equal to 25. Okay, so first you're going to look to see if the bases match. Alright, so we know that's the first thing to look for. Alright, now what if we have one like this, 3x is equal to 14, and the bases don't match? So I can't get them into this form, and I can't look at the exponents. Well, this is like what we did in the change of base formula. If I have two numbers that are equal, then their logarithms have to be equal, so I can take a logarithm on both sides. So there's two different ways that you can tackle this. I can do log base 3 to cancel out here, just like we saw with the log equations. But then I have log base 3 of 14 over here. Not all calculators can handle that. So why don't we do a natural log? Because any calculator can handle a natural log, even the calculator on your phone. So we're going to take a natural log on both sides. Okay, so we take a natural log on both sides, and we do that because now we know this property right here, if you have an exponent, you can bring that down as a coefficient. So we can bring this exponent down as a coefficient. We have x ln 3 is equal to ln 14. ln 3 is just a number, ln 14 is just a number. So since we have x times ln 3, we can divide by ln 3, divide by ln 3, and we've got x is equal to a number. Natural log of 14 over natural log of 3. So you may want to try to put this in your calculator and make sure you can get the correct decimal for it. It should come out to be 2.40. Okay, so when you put this in your calculator, it should come out to be 2.40. Make sure that you can make that calculation. Okay, so let's try another one. Let's say we have e to the 2x plus 1 minus 3 is equal to 5. Okay, e to the 2x plus 1 minus 3 is equal to 5. Alright, so we either want to get to this form, or we want to get to a place where we can take a log on both sides. And to do that, we need to have an exponential that's by itself. So this over here is not going to work for us. We've got to get this exponential by itself. So the first thing that we're going to do is we're going to add 3 to both sides. Okay, so now we've got e to the 2x plus 1 is equal to 8. Okay, now we can look to see, can we get the bases to match? No, of course not, because this is an e and this is not an e. So we're not going to be able to get these bases to match, so we can take a natural log on both sides. So we've got natural log of e to the 2x plus 1 equals natural log of 8. And what happens over here, this is even easier, because remember, natural log is base e, this is base e, and what happens when the bases match? They cancel out. Okay, so this is even easier. This whole thing is going to cancel out, and we're going to be left with 2x plus 1. So we've got 2x plus 1 equals natural log of 8. These are all just numbers, so we need to get x by itself. We subtract 1 from both sides. We get 2x is equal to natural log of 8 minus 1. Now remember, unless this is in parentheses with it, you cannot put these together. This is like the square root of 8. It's stuck inside this function. You cannot put these together, so don't try. Alright, we divide by 2 on both sides, and we get that x is equal to ln 8 minus 1 over 2. Now when you go to put this in your calculator, make sure that you put parentheses around the whole top, and your calculator is going to put parentheses around that natural log of 8. Okay, so when you're putting these in your calculator, don't forget all those parentheses.